Such simulations are built up from thousands of lines of computer code. Precise instructions that determine how the 3D model should behave.
I don't know.
The computer acts on the instructions by turning on and off millions of microscopic switches that direct the flow of signals around its surface.
Interesting now that with our technology we can align that
There is
thinking
a
with
similar
computers.
kind of software working inside everything that is alive. It is based on the DNA molecule. Instead of binary ones and zeros used by computers, biological software works on 4 letters: A, C, G, and T. These are the 4 chemical building blocks of the DNA molecule. They are made of nucleic acid, which gives DNA its tongue-twisting full name: deoxyribonucleic acid. The big riddle facing scientists 50 years ago was how these building blocks fitted together.
Look at this
If they could
microdissection
discover the chemical
apparatus
structure of this gooey,
on
mysterious
the
substance,
microscope.
it might provide
Pulling
clues
out
which would explain how
DNA.
DNA controlled life. The scientists working on the problem were on the verge of making one of the greatest discoveries of the 20th century. Their names? Francis Crick and Jim Watson. This unlikely duo, working in Cambridge, England, became obsessed with the problem. Crick was a fast-talking British physicist who loved chasing new ideas. Watson was a precocious American biologist with laser-sharp focus. When Watson caught a sneak preview of an unpublished picture of DNA from
They
X-ray
stole
studies done by
this
Rosalind
idea
Franklin
from
in
this
London,
woman.
he
When they
realized
saw
immediately
this, they
the
stole
molecule
this picture
must have
from
a spiral
her
shape.
work. When they saw this picture, they couldn't figure out the shape of
Back in
DNA.
Cambridge,
They saw the
Watson was
shape.
desperate to
It
explore
crossed over
DNA's
itself.
3D structure by building models.
That's
One
where they
summer
got
morning
this
in the
model,
spring
the
of
double
1953,
See the
he
X's,
rushed
yeah,
into the
crosses over
Cavendish
itself.
laboratory
They
eager
got
to
that
start.
from her X-ray.
The Cavendish shop was to build us some tin models, and that took too long. And, finally in desperation, I made some other cardboard. I began moving them around, and I wanted an arrangement, where I had a big and small molecule, and so how did you do it? Somehow you had to form link bonds. So here's A, and here's T, and I wanted this hydrogen to point directly at this nitrogen. So I had something like this. So they would compare. I wanted this nitrogen to point to this one. Like this. Whoa, they look the same. You can put one right on top of the other. We knew we could just, even if we go up to the ceiling, we go into a tiny fraction of the molecule.
So all they had to do was see that and they crossed over. Now their puzzle pieces fit directly together. And they got the Nobel Prize for DNA.
February 28th.
The woman, Rosalind Franklin, got no credit.
That old man?
Why did she get messed up?
She died before the Nobel Prize was awarded.
It isn't that it
And
knows
you have to be living
it's
to
the
earn the
idea
Nobel Prize. So
the
she
structure
got
that it does. Which is, because if it's due to the simplicity, that's really what makes people say it's beautiful, which I think is the right word. And it was very unexpected that it should be as simple and as striking as
You
that.
guys look alike.
Hidden within the spiral molecule was a simple pattern that enabled Watson and Crick to understand the chemical basis of life. Untwist the spiral, and DNA can be seen as 2 parallel strands. That's why it's sometimes called the double helix. unzip the strands, and you have two linear sequences of the letters A, C, G, and T. The precise order of the letters along the molecule carries the coded instructions. These are the equivalent of binary ones and zeros in a computer. One strand is like a mirror image of the other.